a good afternoon. I think it's just a good afternoon. Welcome to this REG event. I really appreciate Vattenfall sending such important and knowledgeable people up to brief you all. This is an exclusive REG briefing, so they offered to REG members. And I hope you'll find it really interesting. I have to do some technical stuff first. I'm going to do that because I usually forget, so I'm going to do it now. There are no fire alarms planned for today. If anything goes off, it is a real alarm. In that case, you go out that door, you turn either left or right, you go to the end of the corridors, you'll come to stairs going downstairs. You go down those stairs, that will take you to the car park, which is the muster point. And there are toilets on the left and also on the lower floor, again, if you go down the stairs. So I would hope everyone is aware of this project. I found a very handy shorthand. If you say European Offshore Wind Deployment Centre, they'll go what? If you say it's the one Donald Trump doesn't like, then everyone knows exactly where it is and what it is and what it's all about. So in some ways the man's done us some favours. The project's been in development for a very long time. First proposal was 2003, 2004. I'd like to commend Vattenfall for their staying power once they took it over from AMEC. How long was that now? 6 or 7 years? 2008. Doesn't time fly? The point of this project is it's a relatively small offshore wind project by modern standards, but the point of this project is to learn how to reduce the levelized cost of energy. How can we make offshore wind farms quicker to build, cheaper, easier to maintain? Where can we take cost out? Because what we really need to aim for is a fully commercially competitive industry. At the moment, a lot of renewables technologies are hampered by the fact they need some form of either government support or contractual support, and that is limiting the capability. If we can produce subsidy-free offshore wind, then that means wind farms can be built anywhere that you can get permission for them. The sky's the limit. There will be no capacity limit. So this is a very important step along the way, and I'm sure that Vattenfall will be using the learning for their much bigger projects, much bigger projects than this. And this will help deliver, as I said, eventually subsidy-free offshore wind. Anyway, that's enough from me, because these are the guys you really want to talk to. The biographies are on your chair. I'm not going to run through them all, but I'm going to introduce Adam, who's the project director, to tell us all sorts of interesting things. Adam.
Thanks, Mark. And thank you to Eric for welcoming us today. And you might commend Vattenfall for its staying power, but this project owes its life to AREG, and particularly the transformation of the project from a purely commercial venture to a test and demonstration facility, and the obtention of the 40 million euro EU grant in 2009, and the changing of the project from the Aberdeen offshore wind farm to the European Offshore Wind Deployment Centre. So very good to be here today, and thank you for giving up your lunchtime to come and listen to us. There's three of us here today. Myself, I'm responsible for the delivery of the project, working for Vattenfall, and my colleagues Kevin and Alistair are here today as well. Kevin is responsible for delivering the wind turbine supply and installation contract, and Alistair's been heavily involved with some of the really exciting technological innovations we're deploying on the foundations, and they'll talk a bit more about those later on. So, for those of you who take your dogs for a walk at Balmedy Beach, in a year's time, that's what the seascape will look like. There's no doubt there's going to be a significant transformation of the seascape in this area as a result of our project, and you see the 11 turbines there standing proudly offshore, generating clean electricity to feed into the national grid. The project itself will be generating in excess of 90 megawatts peak power. As Morag alluded to, that is it's quite a modest scale wind farm. If we look at the Beatrice project, which is currently being built in the Outer Moray Firth, that's actually 6 times the scale of this project. But that is a purely commercial venture. Here we're generating a lot of clean energy, but we're also trialing some really interesting and exciting new technology. And as Morag's also said, the purpose of that is to bring down the cost of energy so that offshore wind can be competitive with conventional forms of electricity generation. So Vattenfall, who are we? We are a 100% state-owned Swedish company with operations in 5 European or Northwest European countries, principally Sweden, Denmark, Germany and the Netherlands. UK is the 5th country. UK, we have a relatively low profile because we don't have a customer base. We simply generate renewable energy and sell it onto the grid. So we're relatively little known in the UK. In Germany and Netherlands, we're very, very important suppliers of both electricity and also district heating. So, for example, in Berlin, Vattenfall directly supplies district heating to 1 million customers in Berlin alone. We're the 5th largest generator in Europe of electricity and the 2nd largest generator of heat. Vattenfall actually means waterfall in Swedish. It was originally a hydro company, but of course expanded to meet the needs of power demand. So we generate electricity actually from hydropower, from conventional gas cycle turbines or gas turbines. We also generate power from nuclear power stations, and we have a rapidly expanding portfolio of on and offshore wind generation. We have a target to become carbon neutral by 2050, which is clearly a huge challenge for a company whose business is to generate and sell electricity and heat. But the CEO of the company has stated that that is our goal, and we're targeting 7 gigawatts of wind by 2025. So, obviously the 3 of us working on a project, it's very easy to have the blinkers on and think about nothing else but delivering the project. I just thought I'd share this slide with you, which is some statistics compiled by the BASE, UK BASE department. And what it shows is there have been some pretty revolutionary, or quite a quiet revolution, which we don't hear too much about, but in the way we're generating power in the UK. Historically, our power has been delivered by coal. Coal is disappearing. The government has committed to close all of the UK coal-fired power plants by 2025. Since 2012, there's been an 80% reduction in the amount of power generated by coal, obviously in just 5 years. And for last year, for the first time ever, in March 2016, we went a whole day without burning a single gram of coal to generate electricity. First time that's ever happened since there's been a power grid in the 1880s. So quite a remarkable thing. In April 2016, that was the first month ever where the generation of wind power in the UK exceeded generation of coal. And 2016 as a whole was the first time that wind generated more power or more energy than coal over a year. So last year we had 11.5% of our energy demands were met by on and offshore wind generation. And we now have a portfolio of wind turbines across the UK which have a capacity to generate 15 gigawatts at peak if they're all working together at peak output. And peak demand in the winter is of the order of 45 gigawatts. So a very, very significant portfolio. The amount of electricity generated by coal and gas combined, because of course the reduction in coal has largely been replaced by gas principally, but also renewables. But gas and coal combined has fallen by 38% since 2010, and over 2/3 of that shortfall has been met by increase in renewable energy, and that's the yellow here. So, yeah, a really rapidly changing energy mix, and what you see here is the demand falling. Well, that's 2 things. That's energy efficiencies, but it's also micro generation, so solar panels on your houses. They actually take demand off, so it's a rapidly evolving energy picture, and wind is of course just part of the solution. So solar is also part of the solution, storage solutions, but of course we're here to focus on offshore wind. Vattenfall in the UK, as I mentioned, we're exclusively a renewable energy generator, and with the exception of 5 megawatts of wind generation in South West Wales, it's all wind. Sorry, what did I say? Sorry, with the exception of 5 megawatts solar generation in South West Wales, it's all wind. So we've got 450 megawatts of offshore wind projects in the Thames estuary. That's a really significant large power station, effectively, which we operate out of Ramsgate. We have 150 megawatts in the Irish Sea at Ormond, which we operate out of Barrow in Furness. And then we have a number of smaller scale onshore wind farms. So Swinford in Leicestershire, 22 megawatts. We have Pennacamoid, which is just coming on stream now, which is Wales' largest onshore wind farm site at 228 megawatts. We've got two projects in Scotland, Edinburgh on the Isle of Skye and Clash and Darragh up near Huntly, and this is our first offshore Scottish project at 92.4 megawatts. Morag alluded to some of the larger projects we've got in the pipeline, and chief amongst those are 3.6 gigawatts of planned offshore wind off the East Anglia coast in Norfolk. So, our project in a nutshell, annual production is 310 gigawatt hours. That's enough to supply about 70% of Aberdeen's homes on an annual basis. We have started construction, so onshore substation at Black Dog, just 4 miles north of Aberdeen, is well underway. And a lot of onshore preparatory works are taking place at fabrication yards in the UK and around Europe. Will be commissioned in about a year's time and will be operational for 20 years. Now, I'm just going to show our project film. Which gives a short overview of the project. EOWDC, also known as the Aberdeen Offshore Wind Farm, is a test and demonstration project for the offshore wind industry, which will be constructed in 2018 in the bay behind me just off the coast of Aberdeen. There'll be 11 turbines, and with these 11 turbines we'll be generating up to 70% of Aberdeen's domestic energy demands, and we'll be showcasing some really exciting new technologies in the offshore wind industry.
The wind farm is 2.4 kilometres off the Aberdeen coastline. Scotland is at the forefront of innovation in offshore wind. The northeast of Scotland is leading the way with the deployment centre. Leading this pioneering spirit is the Aberdeen Renewable Energy Group. It was AREG's vision at the turn of the millennium which has got us to where we are today. The 92.4 megawatt deployment centre will feature 11 of the world's most powerful wind turbines, standing at 191 metres tall and generating up to 8.4 megawatts each. Supported on innovative suction bucket jacket foundations and connected by 66 kilovolt cabling. The installation of these wind turbines, paired with the suction bucket jacket foundations, is an industry first. The EOWDC is an important facility that will help to reduce the future costs of offshore wind through the testing and demonstration of new game-changing technologies. The wind farm will be operational for 20 years.
So this project will start construction onshore in the autumn of 2016. At that time we'll also be doing some tests of the novel technologies we're using offshore. In the autumn of 2017, when the majority of the substation works are complete, we'll be moving offshore, where we'll be installing the foundations in the autumn of 2017, the cables shortly thereafter, and then finally in the spring of 2018, we'll bring a heavy lift vessel in to install the 11 wind turbines, and we'll be finally commissioned and generating power, clean, renewable energy power, from summer 2018.
Through two 3-kilometre export cables, the clean electricity generated by the wind farm will be fed to a new onshore substation near the coastal community of Black Dog, Aberdeenshire, and from there to the national grid via underground cables towards Dice, north of Aberdeen. The clean renewable energy generated by the wind farm will power the equivalent of 70% of Aberdeen's domestic demand and 23% of the city's total demand. This exciting project will help establish the northeast of Scotland as a global hub for offshore wind innovation and environmental research. The Vattenfall team and our contractors will focus on building the project safely, setting a new standard for industry best practice.
The substation is going to be constructed behind me here at Black Dog. Murphy's have been appointed as a principal contractor for those works. They are extremely experienced and well known within the wind industry. And we will have a full team of safety within Murphy's and also within Vattenfall supporting that particular part of the project. And over that whole period of time we will be applying health and safety at the highest standard.
The project will help attract other inward investments. It will create long-term partnerships that will contribute to the diversification of the region's economy and future prosperity. Onshore construction of the substation, onshore cabling from the beach to the substation, and connection of the wind farm to the national grid at Black Dog will be delivered by engineering and infrastructure specialist J. Murphy & Sons Limited. MHI Vestas Offshore Wind has been contracted to supply the turbines. Boskalis will construct and install the offshore infrastructure, including the foundations and cabling. The European Offshore Wind Deployment Centre is a showcase for the North East's excellence in energy. It promises a sustainable legacy that will, we hope, generate a sense of local pride in the wind farm and its benefits.
We are setting up one of the world's largest funds for the research of the environmental implications of offshore wind, with £2.5 million committed over the 20-year lifetime of the project. The local supply chain will have a number of opportunities to get involved in the offshore wind industry, thereby helping the diversification process. And with our partners at Aberdeen Renewable Energy Group, we've been able to take a site from conception to a test and demonstration facility and help establish Aberdeen as a global hub for innovation in the offshore wind industry. Yeah, that's a small overview of our substation site at Black Dog. We're building two facilities there actually, a 66 kV building there, which is where the offshore export cables which come from the North Sea here into a transition pit there. There's a short onshore cable route, and those 66 kV cables are terminated in this building here into switch gears. And then we have a larger building here, which will be jointly run by ourselves and She Transmission, where there'll be a large transformer which will step up the power from 66 to 132 kilovolts for export to the grid at Dice, as we showed in the film. Interestingly enough, we're building here on a disused and unregulated landfill site, so that's obviously brought a lot of challenges to us during the construction phase. And there you see kind of our project program at the top there. So everything really hinges on our project critical path, which is March 2018 when we'll start the installation of the wind turbines. And what we're doing now is ensuring that everything's ready offshore and onshore to accept those wind turbines, and to allow them to export power to the grid, which our project economics and subsidy are dependent on. So you see there, it doesn't look like a landfill site, but believe me, there's some nasties in there. An awful lot of landscaping work has had to be done, and excavation work has had to be done in a very sensitive way, because we're working very closely to a small community, obviously, at Black Dog. And now works are well underway, so this is a shot just taken last week, and you can see that's the transformer building there, which is taking shape following the erection of the concrete foundations. So an awful lot of work going on. With regards to the offshore work, one of the ways we keep, it's just like the oil and gas industry, one of the ways we keep costs down is to do as little work offshore as possible. So the foundations are currently being fabricated at a few fabrication sites across Europe. The various components will be brought to Newcastle, at a shipyard there, where they'll be all welded together. There'll be barge transported to Peterhead. Alistair will say a bit more about that later. And then finally picked up by the installation vessel from Peterhead. There, another couple of viewpoints. So clearly we're within 45 miles of Aberdeen Beach. So from this winter onwards, if you go down with a pair of binoculars, you'll be able to keep a close eye on what we're doing. And yeah, it's actually a very rare opportunity to see some pretty exciting construction activity from very close range. So we're now going to move on to the main focus of our presentation, which is the innovation. Kevin will talk about the turbine. Alice will talk about the suction bucket jacket foundations, but I'll just say something about the cabling we're employing. Traditionally, inter-array cabling on offshore wind farms has been done at 33 kilovolts, and the industry's been talking for a long time, as long as I've been involved in it, about moving up from 33 to 66 kilovolts. Why do we want to do that? It's to reduce electrical losses in the system, to enable us to deploy less cables offshore. So by going from 33 to 66 kV, we approximately halve the amount of cable we need, and therefore the amount of offshore work we need to do. And of course, we don't like to interact with the seabed if we don't have to, because we can never map the seabed perfectly. So to reduce risks on our project, it's a very, very handy way of doing so. Something else we'll be doing on the cabling is some dynamic and remote temperature sensing, which will allow us to identify faults hopefully before they occur. Historically, in the offshore wind industry, there have been a number of cable failures which prevent us taking the power that we're generating back onto shore, and this is one of the innovations we're deploying on the project to kind of help eliminate that issue. I think it's time to hand over to Kevin. So, there you are.
Yep, so the wind turbines themselves, we're very happy to be working with MHI Vestas, who will be supplying their V164 wind turbine for this project. So before we get into some of the specific innovations for Aberdeen, it's worth mentioning the turbine itself is actually pretty special. So at the time we install these turbines in March next year, they'll be the most powerful wind turbines installed offshore at a power load of up to 8.8 megawatts each. Some of the Aberdeen project specific dimensions there, we've got a rotor diameter of 164 metres, tip height of 191 metres. And then in terms of, just to give you an idea of some of the weights involved, the nacelle, this part at the top here, that's around 400 tonnes. And each of the blades is around 40 tonnes, so quite a lot of weight, very high up on these structures. The turbine itself is a new model basically, and it's really been built on previous platforms which MHI Vestas have worked with previously. So the Vestas part of MHI Vestas have been producing turbines for many, many years, and they've sort of built up from very small turbines up to these very large ones, and really built on that experience using known technology where as far as possible, but then due to the scaling up and the sort of power involved, some specific departures to make the most efficient solution. So for example, on the smaller turbines, a lot of electrical equipment has been located up in the nacelle here, but the problem is as things get bigger, that equipment gets heavier and heavier and heavier. So to try and reduce the weight up here, a lot of that electrical equipment is moved down now to the tower. We have a DC link between the two. So for example, the heavy transformer is now at the bottom of the tower, for example. Another key thing with the turbine is obviously ensuring it's maintainable and safe to work on, so that's something to really move forward with this turbine. It's got good access ways around all the equipment, and every sort of maintenance task has been well thought out about how it will be achieved. So, what's the sort of background to innovations? Why are we interested in them? Well, there's sort of three key points we're looking to achieve with an offshore wind farm project. We want to obviously reduce the amount we spend in the first place, so we want to use less steel, less components, make the actual wind turbines and the supporting structures as light and as cheap as possible. The next thing we want to do is, over the 20-year operational life, we really want to squeeze every last little percentage of power out that we can. So anything we can do, any little tweaks we can make just to get the most power out for all the wind available, then we're very interested. And then the final thing is, we during that 20-year time, we want to spend as little as possible actually maintaining them. So we want to send guys offshore as little as possible. We want as little downtime as possible. So whenever the wind's blowing, we want them turbines spinning basically. Some of the Aberdeen Pacific innovations that we'll be deploying for this project are listed here. And we'll go into the detail of these over the next few slides. So the first thing to mention is the actual power mode of the turbine. So as mentioned, these, when we deploy them, will be the most powerful offshore wind turbines in the world. We're looking to operate at up to 8.8 megawatts each. and then that sort of increase above the sort of base model turbine gives us an improved annual energy production per year. And what we're basically looking to do is just increase the curve here. And this is around the sort of average wind speed for the site. So anything we can get at this top point of the curve here is very, very beneficial to us. Something we'll be deploying on the blades is vortex generators. This is something you've probably seen on aeroplanes, aeroplane wings, and it's a technology carried over from that, which we want to use on the wind turbines. Basically, what we're looking to do here is make sure the air stays in contact with the blade for as long as possible and avoid the early separation. So what these little devices here do is they move fast-moving air into low-speed air close to the blade surface. That helps avoid this early separation. With this innovation, this is actually a nice one because the improvements get better as the blades get more worn and dirty. So when the blade's brand new, we may only see a very small sort of improvement, maybe 0.3%. As the blades get more worn, more dirty, these really start to have a greater effect and could give us an extra % per year on our energy production. So something we're very, very interested in. We'll deploy something called a park optimised control system. So this is basically a software feature, but what we're looking to do with this is maximise the output of the wind farm as a whole rather than on an individual turbine basis. So in this picture here you can see that, for example, you have several rows of turbines, and in certain circumstances you'll have the wake from the front row of turbines affecting the ones behind it and impacting their output, as they'll be receiving very turbulent air. So what this feature basically does is optimise the entire wind park as a whole. So maybe by turning these ones slightly out of the direction of the wind, you redirect that wake flow. So you may lose slightly on the first row, but you'll gain then on the second and rows behind that. And overall, you'll gather hopefully a benefit across the whole site. So because Aberdeen's only 11 wind turbines arranged across 2 rows, the benefit will be quite small on this particular project, maybe in the range of 0.3%. But the key thing is really testing this technology for future projects where you do have these several rows, and you can really, in that instance, get several percentage per year. So really this is proving the concept for future wind farms and making sure we're really ready for the next projects. In terms of reducing the operation and maintenance of the site, basically each of the tower sections is made up of conical sections which are fastened together by flanged joints, and each of these joints can have up to about 168 bolts each. On current offshore wind farms, we have to send guys offshore every few years to check the tightness of these bolts, check the tension hasn't slackened off at all, and that means a lot of time offshore, a lot of people offshore that we don't want offshore because of the health and safety reasons. So anything we can do to reduce that is a big benefit. So what we're looking to do is reduce this reduced maintenance bolt solution. And this is achieved by a number of factors, but it's basically better bolt quality, a better bolt design, and then also very good flange finish tolerances on, so we get a very good clamp connection. So once we implement this, we hope that basically after the first initial check, we'll then never have to check the bolts again for the rest of the remaining 20-year design life. So this is something we're initially trialling on an onshore turbine at the moment, and then we're looking to get it DNV GL certified to then take offshore. So this is something we're very interested in. It does mean spending a little bit more money up front on the higher quality bolts and the getting sort of high tolerances achieved, but then we get the saving through the operational life through not having to send people offshore. The active side-to-side tower damper is another software feature, but basically what we're looking to do here is reduce the movement of the turbine under wind loads by counteracting that force with torque from the generator and by very fine controlled pitching of the blades. But what we do here is reduce the fatigue upon the steel support structure, which allows us to save steel in the first place and reduce weight. So it's something very beneficial to us. It's something that's already been implemented in the design. We've seen a good result from that. And then iSpin is basically a wind measurement technology. So Across all 11 turbines, each will be fitted with this system, and what it involves is some wind measurement devices placed in front of the blades. So we're measuring the wind before the wind is impacted by the blades. And this is very good for us, because basically what we want to do is throughout the 20-year life we want to be able to compare the incoming wind to the output generation and check that nothing's deteriorating, we're not seeing any problems occurring, and that these turbines continue generating their max capacity throughout the 20-year life. So this is very, very good for us, and also it's very good from the innovation side of things, because if we do implement new technologies throughout the lifetime, we can check on an individual basis exactly what impact that's having and what benefit we're gaining. Okay, so that covers some wind turbine innovations, and I'll pass over to Alistair now, who'll cover the foundations.
Good afternoon. So I'm going to talk a little bit about the suction bucket jacket foundations that we're using at the Aberdeen offshore wind farm site. We've got a short film to show you before I get into it, but I'm just going to discuss the trials that we conducted earlier in the year.
The European Offshore Wind Deployment Centre is Scotland's largest offshore wind test and demonstration facility, which is being developed by Vattenfall. The EOWDC will deploy a pioneering combination of the world's largest and most powerful turbines with game-changing suction bucket jacket foundations, a world first. Conventional offshore foundations are typically monopiles, which are steel rods that are driven into the seabed. The EOWDC will install innovative suction bucket jackets, potentially saving the offshore wind industry millions of pounds. The suction buckets use the sandy sediment of the seabed as a foundation, and as the water is removed from the bucket, the foundations become anchored in the seabed. The EOWDC has conducted several trials of the suction bucket technology, which is virtually noiseless and easily decommissioned by reversing the installation process. So how does it work? First of all, you need a giant steel bucket, which in reality would be 9.5 to 10.5 meters in diameter. These young scientists have simplified the technology using some household materials. Attached to the bottom of the plastic cup, there would be a suction pump, in our case a clear tube. The bucket is then lowered upside down into the water until the bucket reaches the sea floor. Then, by pumping out the water and air, the bucket will be driven into the sand. Let's see that again. This happens because the water is being removed from inside the bucket, reducing the pressure which pushes the bucket down into the seabed. And once it's in place, the suction is stopped and the foundation is installed. At the EOWDC, there is one suction bucket on each of the 3 legs of the jacket. That makes 3 suction buckets per foundation. During installation, the gigantic steel buckets are lowered into the North Sea off the coast of Aberdeen from a large floating crane vessel. From their own weight, they partially sink into the sandy seabed below, and then using this clever engineering technique, the pump attached to the bucket sucks the water out, driving the buckets into the seabed below. Once reaching target depth, they become stuck fast and form a rock-solid foundation for the wind turbine towering high above the waves. The EOWDC will provide an ideal location to showcase the next generation of innovative technologies designed to make offshore wind more affordable. Not only are the world's largest, most powerful turbines being deployed, paired with the suction bucket jacket foundations, but also 66 kV electrical infrastructure will be utilized. Advanced next-generation cabling will transport the energy produced from the turbines to the onshore substation, which will boost power transmission, improving efficiency and reliability. The implementation of this cabling contributes to improving life cycle costs and lowering levelised cost of electricity generated offshore. Aberdeen Offshore Wind Farm Limited, through innovation and next generation technology, is shaping the future of the offshore wind industry for years to come.
Right, so a little bit more about our foundations. Before the project reached FID, we had some geotechnical data from the site that we should assess what would be the best solution for Aberdeen. The geotechnical conditions are actually quite challenging. Just off Aberdeen, we have a shallow layer of sand overlaying some clay, and then a sandstone bottom about 20 metres down. So it actually makes it quite difficult to install monopiles at the site. They're typically installed to about 30 metres depth, so we would have required drilling through the rock to be able to install them. Another option we looked at was a gravity-based foundation and a suction bucket jacket. We ended up deciding on the end the suction bucket jackets would be the best solution, and also would likely be used on future projects with Vattenfall, so a direct place to apply the learnings from this project. So the foundations that we're installing, they range from 60 to 77 metres in height due to the varying water depths for each of the turbine locations. The heaviest jacket is approximately 1,800 tonnes. The suction bucket diameters are 9.5 to 10.5 metres and range in length from 9 to 13 metres throughout the site. So the current status of the foundations, we completed some suction bucket installation trials earlier in the year, which I'll talk about in a bit. The design is more or less complete now. The fabrication is ongoing at various yards throughout Europe, so Belgium, Estonia, Poland and Germany. And currently we're in preparation for the offshore installation campaign that will happen in the second half of this year, only 4 to 5 months away. So the suction bucket trials, we completed 2 campaigns, one in September last year and one in January this year. The main reason behind this was due to the relatively shallow water and the geotechnical conditions. We wanted to find out whether we fell on the lower bound or upper bound estimates to install a suction bucket. Our read today is we were right on the limit if we happened to be on the upper bound estimates. So we got some money and thought we'd conduct 2 trials. The first one was a scaled test using an old subsea pipeline startup anchor, which we modified with a longer skirt. Following on from that test, we had some preliminary results. Due to being scaled, we weren't sure if they would directly relate to a full-size model. So we came up with some refined sort of installation predictions for how much pressure we would need to install the foundations. And we then went offshore in January with what was more or less a full-size model of the suction buckets that would be attached to the bottom of the jackets. Both tests went quite well. The full-size model, we installed it to target penetration at all locations, and the results we got more or less aligned perfectly with the predictions that we had. So very promising for the project, and it shows that we shouldn't have any problem installing the foundations to full penetration at the site. As part of the trials, we also tested a number of contingency installation methods, which proved very effective in reducing the required pressure. So we have a number of different options to install the jackets now at the site. It's more or less just what I talked about just then. In essence, we've got a lot of not only sort of geotechnical engineering results from this test, but a lot of operational lessons learned from the trials, which are now being utilised in the preparation stage for the main offshore installation campaign later this year. So the main benefits of a suction bucket foundation is it's relatively noiseless. The pump would be much less than the other vessel that's operating above it. There's significant savings to be had, not so much in the UK, but in other European projects where there's stringent noise monitoring requirements. You don't need to have another vessel monitoring the decibel levels of a hammer on the monopiles, and also bubble curtains which are essentially just large tube rings that are laid out around the foundation when it's being installed to block the noise. They are not required with this technology. The suction bucket jacket is also more applicable to use in slightly deeper waters, it's up to the 50-60 metre range, which might probably out of reach for a monopile foundation. And then operationally and HSE, there's a number of improvements. It's a small installation spread, as you can see on the top of the bucket there, the yellow frame. That's the suction pump. So there's going to be one of those on each of the jacket's buckets, and other than the main crane, that's all that's needed to install the jackets. So we avoid the need for having large upending tools, hammers, multiple heavy lifts, which obviously is a massive improvement, health and safety wise, for the guys that are working offshore. So the foundations, they're currently being fabricated throughout Europe. They're being assembled into lower and upper sections in Hoboken, which is near Antwerp in Belgium. They're then being shipped in these subcomponents to Newcastle, where they will be assembled into a complete unit. So the 3 suction buckets, the lower half of the jacket, and then the upper half of the jacket will be built into one unit. From there, our contractor Wascalas will pick up the jacket, 2 at a time on a barge, and transport them up to Peterhead, which will be our base harbour during the installation operations. We'll have 1 barge moored there at all times. There'll be 2 barges ferrying the jackets back and forth. The installation vessel, the shear leg, Asian Hercules 3, it will pick up the jackets in Peterhead and then sail the 7 nautical miles down the coast to the Aberdeen offshore wind farm site. With the jackets suspended in the hook, it will then moor up on anchors and lower the jacket onto the seabed. From there, we expect a couple of metres of self-weight penetration, and that's enough to provide a seal to the soil around each of the suction buckets. And from there, the pumps are turned on, and the bucket will sink into the seabed. We estimate approximately 4 to 6 hours from the vessel arriving on site and lowering the jacket to the foundation installation being complete. We have a penetration rate of about 8 centimetres per minute once the pumps are at full speed. Once that's done, the cables will be installed, which I talked a little bit about earlier. But then the main show is the turbine installation, which will occur in March next year. We'll be using a jack-up vessel at the site, a 6-legged jack-up vessel, the Pacific Hawker specifically. Again, it's a very challenging site for jack-up vessels due to the sand on top of the clay. Those of you familiar with the oil and gas industry, we have quite a punch-through risk with this kind of conditions. So a lot of work's being put in at the moment to make sure that the operational procedures and the site-specific assessments have been done adequately to ensure that it minimises the risk of a punch-through occurring to as low as possible. Due to the size of these turbines, the hub height being 106 metres, and the width of the foundations, and the spud can from the jack-up vessel interacting with the suction piles, we actually have to have the jack-up vessel located quite a way away from the foundations. And because of that, we've had to select a really quite a huge jack-up vessel with an enormous crane on it, just to be able to have enough lift height underneath the crane to even be able to install wind turbines. There'll be 3 trips, each with 4 turbines, the final one having only 3 turbines. They'll be picked up in Esbjerg, whereas MHI Vestas will pre-assemble the turbines. They'll be loaded on board the vessel. It'll sail across the North Sea. Then we anticipate once the vessel is set up at each of the turbine locations, approximately 24 hours per turbine for installation. So I'll hand back to Adam now just to go more into thanks.
Yeah, so just a few quick words on the science. The science panel has been set up, jointly funded to the tune of €3 million by Vattenfall and the European Union. We launched the scheme last autumn, call for papers, or call for proposals rather. We actually had, as the graphic shows there, nearly 90 applications, which we were thrilled with because, of course, it's quite a narrow focus, really. You know, the socio-environmental implications of offshore wind. So to receive so many responses, and so many local to the northeast of Scotland was really good. We've shortlisted projects at the back end of last year, and we're just later on this month we'll be announcing the successful projects. The scientific panel, well, Vattenfall and ARIC both sit on the scientific panel, but there are also a number of key stakeholders, mainly from the consenting side of offshore wind in Scotland. So we have Marine Scotland, the Scottish Government, SEPA, JNCC, SNH, RSPB, and the Crown Estate. So we're really bringing together the key players, really, in the consenting process for offshore wind farms in Scotland. It's very exciting. There will be further projects in the future and in the O&M phase, because, of course, the test and demonstration site, yes, we've included a lot of innovations in the construction phase, but it's going to be sitting there for 20 years. It's 15 minutes sail from Aberdeen Harbour. It's a platform for testing new innovations in the O&M phase also. So your companies, or companies you may represent, may be interested in coming to us and talking about innovations that you can trial at our wind farm. And you know, we're based down in the regional centre, so please come and talk to us if you have any ideas that you'd like to discuss with us. We don't have any colleagues from our O&M department here today, but basically what we're looking for, it's as Kevin said earlier on, we're looking for anything that might reduce the operational expenditure of our wind farms. And okay, here we have a very straightforward wind farm to get to from a geographical perspective, being so close to the harbour. But we operate other wind farms in the North Sea, particularly the German sector, where it takes in excess of 3 hours sailing to get to the wind farm. So we want to cut out expenses, principally for safety. Clearly, there is a very big contribution to the running costs of the wind farm from unnecessary intervention. So what we're looking for is remote monitoring and drones to do blade inspections, for example. Anything that improves the availability of the turbines. So actually, we've got quite a good track record in the industry of having very high availability of turbines, in excess of 98–99%. But that's something, I mean, even by increasing that to 99.5%, that is a significant achievement for us, because it means that these turbines are available to generate when the wind blows. So, Alice has mentioned a lot about the suction buckets. Now, it's rather an old technique in the oil and gas industry, but it's quite revolutionary in the wind industry, and the reason it's so different is because we have to support an extremely different loading regime. We're effectively trying to hold an A380 at takeoff still that's suspended 130 metres in the air. So there's huge forces that we have to resist. What do we do as engineers when we're uncertain and unsure about loads? We add in conservatism, we add in safety factors. So if these foundations were planes, they would never have got off the ground, because there is a lot of excess fat and excess steel in them, simply because of the uncertainty in the design phase. That's something that we have to cut out going forward to reduce the cost of energy for the projects that are coming further offshore. The other thing we're looking for is, of course, when we have to do repairs, we want them to be as long-lasting and as quick as possible. So that's something else that we're very interested in. And of course, performance optimization of the turbines. Now, Vattenfall actually has a platform on its website. The link is within your information pack, where any research and innovation ideas, not only in the wind industry but also in the wider power industry that we operate in, can be registered. So please, if you have any ideas, that's the place to go to. So hopefully that this talk we've just given you has shown you that we're really trying very hard with this project to employ innovations that are going to help us reduce the cost of energy further. We've actually got a very good story to tell in the offshore wind industry. The industry set itself a target for 2020 of £100 per megawatt hour. That's already been beaten last year, because the new projects that were coming on stream last year were at £97 per megawatt hour. But we have to go further, because the generous subsidy schemes that have been rolled out in the UK and other countries in North and West Europe, they're not going to last for very much longer. So we've got to continue to drive down the costs. And as Kevin mentioned, it's about reducing the capital expenditure. It's about increasing the production from the turbines we have. and managing their performance over the lifetime. So yes, in the last 5 years we moved from 3 megawatt turbines to 8 megawatt turbines. That clearly makes a huge difference. But now we're at 8 megawatt turbines. We have the smaller, squeezing as much energy out of those turbines with these innovations that Kevin mentioned, which is really critical to making those kind of marginal gain improvements that we must see. And finally, of course, reducing the operating expenditure. So hopefully that's given you a quick overview of what we're trying to do with our test and demonstration project. So please address any questions to the three of us. Thank you.
Question for Kevin. I'm Tony coming from Starless, and we're specialised in inspection, maintenance and cranes. And one of the challenges we have is on the boats with regard to the slew bearings on offshore cranes. You described there the challenges with the bolts and the towers themselves. So there's two sort of like questions I've got for you. One is, have you looked at the online monitoring of those? And the second part is, within our environment, we've got to do a 20% change out every year so that you achieve 100% change out, so that you have to make an intervention to change the bolts over a 5-year period. Does that apply, and have you looked at other smart technologies to actually look at the bolts?
Yeah, so as mentioned, we're actually trialling the new bolt technology on an onshore turbine at the moment, actually, and some of them are sensored up, actually, so we can actually see in real time whether the tension is being reduced over a period of time. We hope to have that basically closed out by the time we install them on the offshore turbines, so we won't actually actually put sensors on them is the intention. But it is something we have looked at in the past, actually, is do we put a few sensors on as well, just to get a bit of comfort feeling. Yeah, on the change out, it's not something we have to come across in the moment. The bolts are sort of over-designed to last the design life and stuff, but at the moment it's really checking the tension, and at the moment I think we usually retension maybe about 10-20% go round each interval effectively.
Okay, thank you. For Kevin as well, and that was, you mentioned on the vortex generator, sorry, John always see what it's red on vortex generators, you said the blades get dirtier, get warm, and that improves performance. Yep. Is there any way of pre-wearing the blades before you install them so they start optimised?
Really, we want to keep the blades as clean and as the profile as good as possible, really. So, because as that goes, the performance goes down. We're obviously trying to pick it back up again by these vortex generators. But a lot of research and time goes into looking at the sort of coating, especially the leading edge, which takes a lot of impact from rain. So I did a quick calculation with the size of the blades. Although the rotational speed is only sort of about 10 revolutions per minute, the actual speed of the tip is very, very high, several hundred mile an hour. So when the raindrops hit that, it's really quite an impact force. So a lot of technology goes into actually the coatings of the blade as well. But no, we've not really thought about pre-eroding them effectively. We want to try and keep those as good as possible for as long, really.
It's the contribution of the vortex generators which is increasing over time, because as the blades get worn, it's picking up more of the delta.
Yeah, so it's effectively filling with degradation.
Exactly. Yeah, exactly.
Okay, thank you.
Come on, someone must have something burning to know.
One of the things that the oil and gas industry does brilliantly well is make everything bespoke every single time. Yeah. And I'm interested in what you guys have done in terms of trying to bring in as much standardisation as possible, because from a sort of spares and replacement point of view, obviously that makes things a bit cheaper as well.
I would say that we have the potential to relegate the oil and gas industry to second place in our inability to standardise. It's certainly a challenge that we have. I mean, we see it's really difficult. We do have aspirations to standardise everything, because, as you say, it's a really easy win. But for example, the foundations, they have to be designed on a case by case basis. there are innovations, or there are kind of aspirations in the industry to come up with what they call a standard foundation design. But once you go below the splash zone, it doesn't really. There's no point, because you have to design for your specific wave conditions, specific seabed conditions, etc. I think now the turbines are becoming quite standardised.
Exactly. So we're especially looking at this turbine for future projects as well. Yeah, the intention is very much that we have a sort of combined spares strategy and sort of central hub for maintaining these turbines. Really, because we want to sort of keep as low spares as possible, but then have them available for as many wind farms as possible. Yeah.
But you've got to remember, we're a very new industry, and the first wind farm, offshore wind farm, is 10 years old, 10, 12 years old. And obviously, initially we were 1-2 megawatt turbines, now we're 7-8 megawatt turbines. And of course, every time there's a new turbine, then almost all of the standardisation that we've tried to implement has almost gone out the window. So it is a real challenge.
Because as sort of Adam mentioned, turbine size has increased massively over the last few years. On our last project, which we've just finished in Germany, called Sandbank, they were installing 4 megawatt turbines. At Aberdeen, we're looking at 8.8 up to 8.8 megawatt turbines, and then early 2020s we could be looking at over 10 megawatt turbines, 15 megawatt turbines. So it's a really rapidly advancing industry. It's one of the key factors to driving down cost actually has been the sort of rapid turbine increase, because you need to get 100 megawatts, you need less turbines, less foundations. It really helps on economies of scale.
It does, and of course we're still making a hell of a lot of mistakes. So we're having to learn a lot of lessons. So by definition, in implementing the lessons we're learning from the future projects, we're not standardising. And of course, our Danish colleagues might go in one direction, our German colleagues might want to go in another direction, and there's different company strategies, and there's also different legislative requirements. So it's a very noble aspiration that the industry has, but we're a long way from achieving it.
I think it's probably also worth mentioning on the foundations, a lot of work has gone into monopiles. They've been the sort of base case solution for many years now, but we do see a limit to them, and Vattenfall very much see the suction buckets as something coming in to their own over the next few years, the sort of water depths over the next few sites coming up, so especially the use of this technology at this site will be very useful for us.
One of the interesting things, we don't mention anything about this because we're specifically looking at the innovations on our project, but the sites, we don't really have that much control over the sites where we're building our wind farms. And something that's contributing to actually kind of fighting, we have to fight against in the aspiration to reduce cost, is we're moving into further deeper waters, further offshore, which increases O&M, it increases your capex because you have to. You've got to resist a larger force over a larger moment area in much harsher conditions. So really, there's something to be said again for going back to the sites that we know and love. And for example, the last project I worked on was actually an extension project where we came and built turbines around an existing wind farm site. Well, that was absolutely ideal because you know your site, you know your conditions, you've already got an O&M base nearby. And it really becomes then a plug and play solution. Your risk profile is a lot lower. So, going out to Dogger Bank, it's a hell of a long way offshore. The conditions are really harsh, and if you've got a problem with your turbine, it could be days before you can get out to fix them. It's a good question and a very hotly debated topic.
John Barrow from Cost Subsea. What construction technique are you using to bring the cables through the surf zone, the export cables through the surf zone and across the beach?
We're ducting them. We're constructing trenches that will take us from. We've got actually quite a complicated landfall because there's a stream of burn that comes in at Black Dog, which we have to go under. So there'll be a trench that's excavated. We have to bury the export cables to 1.5 meters deep. So we'll excavate a trench. That will take us to approximately 250 meters offshore and about 4.5 meters water depth. We'll pre-install ducts into those trenches, and then we'll come and pull the cables in when the time comes. The other method that's commonly used in offshore wind farm is horizontal directional drilling.
But Brian Little, Horcon, just interested, what's your strategy in terms of warranty with your, particularly with MHI Vestas? I mean, 5 years, 10 years, what's...
Yeah, can I take that one? Yeah. Basically, it's a 5-year sort of warranty to start with. We then have options to extend that, but Vattenfall's strategy is very much we take over the maintenance ourselves after that 5-year period. So, to give you an idea of what the operational phase looks like, for the first 5 years we'll be operating joint teams. So we'll have technicians from MHI Vestas and Vattenfall technicians working together, building the experience, and then the plan is really, after that 5 years, we'll look to take over the whole operation of maintenance ourselves, based from our Aberdeen base in the harbour.
Yeah, whereas from the get-go we will maintain the foundations and cables and the substation, but the turbine is obviously different.
So would you say that's good news for local content and local suppliers?
Yeah, definitely,
Yeah, but I mean, I guess in comparison to MHI Vestas, which obviously a much bigger operation, turbines all over the world, and I don't know, do they have a service centre up here in Scotland? I guess they do.
Well, we're actually going to share a service facility with MHI Vestas at the harbour,
right.
In Commercial Quay in the harbour.
Right.
And
I think this is MHI Vestas' first sort of Scottish offshore wind farm as well. So they're starting a bit fresh as well here, to be honest.
And they've made a couple of local appointments already, actually.
Yeah.
So they've got people working on the ground already.
Okay, thanks.
Yep.
Hi, Jacqueline from Red Five. It's possibly premature to ask this question since it's still in its construction phase. But is it a fair assumption to assume that with the suction jackets it will be easier to decommission in 20 years' time as well?
That's very much.
Has that been built into the plan?
Yeah, that's so. As part of our consent, we have a consent condition where we have to send a decommissioning plan to Marine Scotland, and certainly decommissioning of the suction bucket jackets should be a lot more straightforward than traditional monopiles, where actually you leave hundreds of tons of soil, hundreds of tons of steel in the soil forever because you can't remove them. But with the suction bucket jacket, you just reverse the installation process and lift the thing out of the ground. And by the way, that could also be beneficial during installation if we have any nasty surprises. Whereas traditionally you're driving piles. If something goes wrong, I'm afraid that's it. With these jackets, we can. If something terrible happens, it's not the end of the world.
As part of our trials as well, we did 10 different installations. So each one we were just installing them all the way and then just immediately push them up. And it's the exact same speed as installation, so you could have one removed, in 4 to 6 hours as well.
So it's not a premature question because it's something we have to factor in there. Something like.
Sorry, hi. Rod Hutchinson, Leading Chalmers. So this 20-year sort of lifespan, if you like, for the facility, is there any prospect of that being extended or changed from research to be supplemented with commercial, or is it very much a fixed 20-year research development site?
So our consent with the Scottish Government is for operational life of 20 years. We're designing the wind farm for 25 years, and that's simply because we don't have really a choice in the design life of the turbines. It's simply provided with a design life of 25 years. So our view is, why not spend a few more pennies at this stage and make sure the whole wind farm can generate for 25 years if that's necessary. But we don't know what's going to happen when we get to 20 years' time. I mean, it'd be very hard to imagine that if you've got a fully operational, functional wind farm, why would you decommission it? And I remember standing about 10 years ago, standing on the Le Mans Alpha jacket in the Southern North Sea, which was built in 1967 with a design life of 10 years. So I think we'll probably see the same pattern emerging in our industry. But 20 years is limited, but we're limited by the consent at the moment.
In terms of overall strategy for Vattenfall, have you got a strategy for nearshore wind farms? You're mentioning moving further offshore, maybe into floating wind and things like that as well. But is there anything that the company's got that is directly in that
Okay, so our pipeline at the moment is actually full of relatively shallow water sites. So in 2015 and 16 we won tenders in Denmark for projects, one called Vesterhaven Nord and Syd, which is also known as Danish Nearshore, which is off the west coast of Denmark. And we also won a tender last year for, that was also 2015, Montreux 3 project, which is about 15 to 20 metres water depth, and that's going to be built just after the EOWDC. We also have another project on the Baltic side of Denmark, which is again relatively modest water depths. Coming to the UK, we have plans of the Thanet wind farm, which is 300 megawatts, which we've been operating since 2010. We do have plans to extend that. That is again 20-25 metres water depth. And I mentioned at the start of the presentation the Norfolk projects. Now the Norfolk project, the water does get a bit deeper, so we're up to 50 metres there. So we are very much at this stage focused on fixed foundations. That's what's going to suit our site. If you look at our colleagues from Statoil who are building the demonstrator at Buckendeep off Peterhead, they're using floating technology, which of course beyond 60-70 metres, floating wind's going to be the answer. And that of course suits the Norwegian topography. So it's not something we have direct plans for at this stage, but we've got to get 7 gigawatts in the water in the next 7 years, so we're going to have to be very open-minded about the kind of technology that we deploy.
Yeah, it's maybe also worth mentioning the different regulatory frameworks in the countries as well. So in the UK, the developer such as Vattenfall has to have a project and take that into an auction system, and basically other developers will be doing the same. Whichever project gets the lowest price basically will win. On the continent, the system that is working at the moment is the actual government has the project, and then the developers bid to build that project, so that it's really the government deciding where to put the projects more than the developer effectively. So some different systems.
Right, I think we'll wind up this formal Q&A just now. I think you're going to be around for the next half hour or so.
What's the plan?
So if you've got if any burning questions didn't get asked, the Vattenfall team are going to be here for the next half hour. We've allowed half an hour for networking and give you something to eat before you have to head off to do whatever it is you have to do next. I thought it was a very interesting presentation. I know we talked about doubling the size of wind turbines in the last 4 years. The original proposal for this project was for 2.3 megawatt turbines. Admittedly, that was a long time ago, but it's amazing how the industry is gathering pace in terms of development. So we took 10 years to get from 2.5 to 2.3 to 4, and we've taken 4 or 5 years to double that. I think the other thing that's quite clear is this project doesn't end when it's constructed. There is so much to learn. There's so much we need to find out still how to do, and I know we regard it as a very valuable commodity. As Adam says, it's not very far from the coast. It already has an innovation component, and the local ambition is to try and build a science and technology base around this development, which will have an impact on offshore wind across Europe and possibly around the world. The other thing I think that's been underestimated is the actual value of O&M for offshore wind. Everyone focuses on the construction. In actual fact, the O&M cost can be a significant proportion of the construction cost over the lifetime of the wind farm. So enough technical stuff. Hopefully you've all got things to talk to one another about. As I said, the project team will be here for another half hour, so if you want to speak to them individually. And thank you for coming. Do watch your emails, and John, yes, we will check your email address. Do watch your emails for meeting invitations. We are currently planning the rest of the programme. There will be another 5 lunch and learn type events like this. There will be another 4 or 5 AREC members meetings. When you get your newsletter, if you look down your side, you will see there's a list of events. AREC is actually attending quite a lot of events over the next year to promote you, our members, and to try and generate new inquiries. It's worth checking. If you're going to be at those same events as we are, then we should all get together. Okay? So have something to eat. do some good networking, and good luck for whatever it is you've got to go and do next.